Welcome friends, let's do a series for f of x equals 1 over 4 plus x squared. You can do this from scratch by differentiating, finding the coefficients, but it's more elegant if we just take 1 over 4 plus x squared and just write it as 1 over 4 first. Factor the 4 out, that's going to leave a 1 plus x squared over 4 this way. So notice that you have to place a 4 in the denominator under the x squared, because if you brought the 4 on the outside back across, it would cancel, giving back x squared. And make sure you leave a 1 here, because over here this means 4 times 1. And then look what happens next. We can rewrite the plus in the middle as two minuses, so we'll have 1 over 4 and then 1 minus a negative x squared over 4 is shown this way. Now, why would we want to do this? Because what we can do is plug this into the following. Take the 1/4 and just separate it away, and then you have 1, and then minus negative x squared over 4 this way. This fits into the pattern for 1 over 1 minus u of x now, you see? The 1/4 is completely separate from it. Don't worry about it. So that means the following. We can say that this is 1/4. In this part, you can replace with the summation, as n goes usually from 0 to positive infinity, so it's a 0 down here. And then just put negative x squared over 4 and its quantity raised to the n this way. Radius of convergence, you have the following: negative x squared divided by 4. This should be less than 1 usually. So the fact you're taking absolute value will get rid of the negative. And then that's going to give you then the absolute value of x squared over 4 is less than 1. As shown. Notice that this gets rid of the negative pretty much, because you can apply the absolute value bars to the negative separately, get rid of it. Anyways, that's going to give you then negative 1 is less than x squared over 4, less than positive 1. Then you multiply across by 4. So you're going to have negative 4 is less than x squared, less than 1, less than 4 rather. Now you have to ask yourself about the numbers that make this true. To think about it. So if you have trouble solving this kind of inequality, let me show you maybe a graphical approach that might be useful. Notice I said might be. Everybody's different, I guess, differently. So if you just think about x squared, what that is just a parabola after all. So what you can do is graph it. Let me show you. Just graph x squared. And it's trapped between the lines negative 4 and positive 4. So graph. Okay, it's all the way up there, that horizontal line. You can also graph negative 4 on the other side of it. That's all the way down below. So kind of like this. Hold on, let me see. I need to enlarge this a little bit. Okay, kind of looks like this. All right. So the positive 4 is all the way up there, right? The negative 4 is all the way down there. Let me scrunch this down. Hopefully you can tell, therefore. All right, now look, this is true when x is between negative 2. Look very carefully, and x is going up to positive 2. That's where this is true, this inequality right here. This inequality is true. So let me kind of emphasize this one more time. You see, if you go from right here, between negative 2 and positive 2, you see that the negative 4 is less than the parabola, which is less than positive 4. And this is true all the way across to positive 2 right here, you see? Right here. Because the parabola is below the green line, and the red line is below the parabola, which is what this says. The endpoints are not included because of the less than parts. So if you look along the x-axis, therefore the solution to that is negative 2 is less than x less than positive 2. Again, let me stress this, because sometimes you see this is 0 here, well, negative 2 rather, right? And this is positive 2. But those values themselves are not included. But any value that you can imagine between them is included. All of these are included, you see? So those begin at negative 2 and go over to positive 2. That's why the inequality that solves that is this. Let me stress something. If you look at a graph of 1 over 4 plus x squared, let's look at that. This is a bit of a mystery, really, if you think about it, because it doesn't come from the graph, okay? So what do I mean by that? Look very carefully. Okay, let me graph this right here. So graph 1 over 4 plus x squared. When you graph it, you see it looks like this. Let me kind of stretch this out this way a little bit more. There are no vertical asymptotes in this graph anywhere. If you look at it, you see? Doesn't matter how you scrunch this, you see there are no vertical asymptotes. Like there does not appear to be any reason why the radius of convergence would just be, for example, 2 units, or you would just basically be able to plug in values from -2 to +2. If you look at the graph, you see like why can you not plug in -4 or +6 or some number like that? The reason is that think about the complex plane a little bit, okay? So that plane is really like a two-dimensional object, and there you can have numbers like 2i, correct? In that plane, it's like z equals 2i. That's a possibility. But look what happens if you plug in 2i. You would have 1 over 4 plus 2i squared, and that would be 1 over 4 plus 4i squared. But I squared is -1, so you'd have 1 over 4 minus 4, which is just, in other words, then at the very end, 1 over 0, which is d and e. It doesn't exist. So that shows up here in this fact, even though the graph of the original function does not appear to have any asymptotes. They're coming from the complex plane. They're coming from, another dimension, so to speak. Anyway, I'll leave it here, so leave a like if it's been helpful.